Hi, this is Mrs. Yamamoto, and this video is going to go over in more detail each question from the first test with an explanation for each question. For number 1, the question says, which of the following is equivalent to 8/9? So equivalent means equal. I take 8/9 and then convert it to a decimal. The 8 is repeating. So if the 8 is repeating, then my answer is 0.8 with a line over it. Number 2, Silas wrote a number as a fraction with an integer in both the numerator and the denominator. Which of the following statements correctly describes a number? So if an integer is in the numerator and the denominator, then you have a fraction. And if you have a fraction, then your answer is rational, not irrational, since rational numbers can be fractions. Number 3, is 0.7 with 7 repeating a rational number? So first thing you want to realize is that the line over the 7 means that the 7 repeats on forever. So the answer to this question is D. Yes, because the digit is repeating. Number 4, is the square root of 15 located between points M and N on the number line below? So on the number line here, I put what the square root of 1 is equal to. On the number line, it's equal to 1. The square root of 4 is equal to 2. The square root of 9 is equal to 3. And the square root of 16 is equal to 4. So the square root of 15 falls between the 3 and the 4, which means the answer is C, yes, because it's greater than 3 and less than 4. Number 5, where would the square root of 7 be located on the number line below? The square root of 7 would be located between P and Q, closer to P. Number 6, which of the following statements is correct based on the number line below? So the correct statement is D. The square root of 68 is to the right of point Q because it's greater than 8. So the square root of 64 is equal to 8, so the square root of 68 would be greater than 8. Number 7, which of the points plotted on the number line could represent the square root of 5? So here, the square root of 4 is equal to 2, the square root of 16 is equal to 4. So the square root of 5 would be right after the square root of 4, so it would be at point H. Number 8, 8 to the power of 3 times 8 to the power of 7. 8 to the power of 3 is broken down as 8 times 8 times 8, and 8 to the power of 7 is broken down as 8 times 8 times 8 times 8 times 8 times 8 times 8. So here I have a total of 10 eighths, which means that my answer is A, 8 to the 10th power. Number 9, negative 4m to the 3rd power times 8m to the 7th power. Here I multiply my coefficients and I get negative 32. I have the same base of m. When I have the same base, I add my exponents and I get m to the power of 10. So my answer is C, negative 32, m to the power of 10. The next question, here I have 12x to the 3rd power, y to the 4th, times 5x to the 6th, y to the 3rd. So I'm going to multiply my coefficients, and then I'm going to add my exponents because I have the same base of x, so 3 and 6 make 9, and I have the same base of y, so 4 and 3 make 7. So here, remember, when you have the same base, you add your exponents. Number 11, 3 to the power of 6 raised to the power of 3. So 3 to the power of 6 would be 3 times 3 times 3 times 3 times 3 times 3. So 6 threes. But I see I have an exponent of 3, so I'm going to write that out 3 times. So altogether I have 18 threes, so my answer for number 11 is D, 3 to the 18th power. Number 12. Number 12 is 8 to the power of 10, then raised to the power of 2. So first I'm going to say, okay, 8 to the power of 10, I'm going to write out 10 eighths. And I'm going to do that 2 times because I have an exponent of 2, so I have a total of 20 eighths. Number 13, which expression is equivalent to 5x squared y to the power of 3? So here the 3 gets distributed to each term. 5 to the power of 3 is the same as 5 times 5 times 5, so I get 125, and x to the power of 6. 6 comes from multiplying the 2 and the 3, and then y to the power of 3 comes from multiplying the 3 and the 1 as a coefficient of y. And number 14, here I have w to the power of 9 divided by x to the power of 4, and all of that is raised to the power of 3. So here, 3 gets distributed both to the numerator and the denominator. So I get 27 from multiplying 9 and 3, and I get 12 from multiplying 4 and 3. So my answer is w to the power of 27 divided by x to the power of 12. So my answer to number 14 is B. Number 15. Number 15, I'm going to distribute the exponent to each term. So here, 3 has been distributed to both the 3, the a, and the b. And then in blue, the 3 has been distributed to the a and b. When I simplify and combine my like terms, I get 27 to the power 27, a to the power of 6, and b to the power of 15. Number 16. Number 16, here I have 7 to the power of 8 divided by 7 to the power of 3, and I'm going to write it out in factored form. When I simplify, see I have 5 7s left on the top, so I have 7 to the power of 5. Number 17, here I wrote it out in factored form. When you write it out in factored form, you can see what you can simplify by canceling out certain terms, and you're left with 1 9 on the top, 2 x's on the top, 1 y on the bottom. Number 18, which choice has the same value as 1 divided by 2 times 2 times 2 times 2 times 2 times 2? So I have 6 2's on the bottom. 1 divided by 2 to the power of 6 is the same thing as 2 to the power of negative 6. That's our negative exponent rule. So I have A, 2 to the power of negative 6. Number 19. Number 19, here I have 5 to the power of negative 4. My negative exponent rule states that I can flip that to the other side, and I have now 1 divided by 5 to the power of 4, and I rewrite that in factored form as 1 divided by 5 times 5 times 5 times 5, so D is my answer. Number 20. Number 20, same thing, my negative exponent rule. I'm going to flip that to the other side of the fraction line, and I have 1 divided by 3 times 3 times 3. 3 times 3 times 3 equals 27, so I have my answer as D, 1 divided by 27. Number 21, here I have 4 to the power of 5 divided by 4 to the power of negative 6. 4 to the power of negative 6 moves to the opposite side of the fraction line, and it combines with 4 to the power of 5 to make 4 to the power of 11, and I simplify and get C, 4 to the power of 11. Number 22. Number 22, I have x to the power of negative 4 on the bottom. In blue, you can see that's moved to the top, and now it's in a positive exponent form. 32 divided by 16 simplifies to 2 over 1, and I get x to the power of 10 because I'm combining the 6 x's with the 4 x's to make 10 x's. And number 23. Number 23, both terms have a negative exponent, so both terms flip to the other side of the fraction line, and then I write it out in factored form. There are 5 7's on the top, 3 7's on the bottom, and I simplify and I have 2 7's left on the top, so I have 7 to the power of 2. Number 24. Number 24, I'm asked, what is the square root of 9? The square root of 9 can be broken down into the square root of 3 times 3, so my answer is 3. With square roots, I have to make sure underneath that radical sign, I want 2 identical factors. Number 25. Number 25, I have negative square root of 81 divided by 144. So negative square root of 81 divided by 144 can be broken down as 9 times 9 divided by 12 times 12. And here I simplify, I get negative 9/12. But negative 9/12 is not one of my answers because negative 9/12 has been simplified to 3/4, and 3/4 is D. Negative 3/4 is D, my answer. Number 26, the square root of 400 is, so the square root of 400 can be written underneath here as you see with the radical sign. I have to think of 2 identical factors that multiply together to give me 400, and that number is going to be 20. 20 times 20 will give me 400. So the square root of 400 is going to be 20.